Thank you, ladies and gentlemen. Please take your seats. The session will begin momentarily.
Ladies and gentlemen, please welcome to the stage Tad Buman at Expedia Group.
Good morning. Guiding principles, engineered fact tables, and simple, intuitive self-service analytics. Those are heady topics with which to start your TC18. Good for you all for being here, and thank you. Our collective group at Expedia has been around a long time, and we've done a lot of things, some of them right and some of them wrong. But we've also had the opportunity and the longevity to see the difference. So today you'll learn about guiding principles, engineered fact tables, and simple, intuitive, familiar self-service analytics. Tableau's tagline is help people see and understand data, and it's fairly easy to create a data mart for BI data people that know the data. My intent today is to show you how to create a data mart that's accessible and usable for everyone in the organization. I'll talk about who we are. I'll tell you about our technical platform today. You'll learn about our product. And finally, you'll understand by the end of the presentation how we implemented self-service analytics at Expedia Group. Expedia Group is a global leader in online travel, thanks to all of those of you that booked using Expedia to come here to NOLA. Expedia Group does business in 200 countries and territories, $10 billion in revenue, and hundreds of millions of transactions in 2017. As part of the Consumer Payments Group, our purpose is to report on how effectively Expedia is collecting payments from qualified customers. In addition, credit card processing is incredibly expensive. I wasn't supposed to say the actual number, but it's a big number. And so we need to be able to analyze the cost associated with payments. So for that, we needed an analytics system that was fast, reliable, scalable, and that we were ultimately confident in releasing to our non-technical business users. So today, I'd like you to think about guiding principles. We started out with guiding principles. I'll show you our guiding principles and encourage you to think about your own. Embrace the impermanence of the cloud. This is a very different paradigm for us. We used to order hardware and then wait for procurement to finally get the hardware and then get it installed in a data center somewhere and then turn it on and leave it on. With the impermanence of the cloud, you use what you need when you need it, just like these blue bikes out here. You don't need to buy a bike. You don't need to have a bike. You just get your bike, ride it to the conference, park it, and you're done. Same way with the impermanence of the cloud. Finally, the end product should be usable and familiar. Our users were using Excel pivot tables with a SQL Server Analytics Server back end on it. So we wanted to make something that they could open up and say, oh, I get this, I understand this. We tried to change the paradigm as little as possible. Guiding principles maintain focus when designing and building the data framework. So this is our guiding principles for when we created our data mart. We wanted transaction-level data. Our company roadmap said that we needed to be in the cloud, so we wanted to be cloud-ready, if not 100% in the cloud. We wanted standard loosely coupled interfaces. I'll explain a bit more about that later. I have an example using JSON files. We wanted to be sure that we were horizontally scalable, so that as our data and the attribution that we collected grew, we could scale out horizontally, and performance would never be an issue. Finally, the end product had to be simple, intuitive, and self-service for our customers. Look, we didn't want to be report writers. I don't want to just sit and write reports for everybody else all day long. We wanted to be analysts and allow our customers to do their own self-service. Now you'll hear a little bit about our product and platform. Our core product is engineered fact tables. Engineered fact tables allow you to take transactional data that doesn't necessarily make sense in an analytic format and turn that into business context. We have managed metrics. We were very careful and deliberate about making sure that our metrics were exactly what the customers needed and what most of our customers needed. They're centrally located and centrally governed, so everybody uses the same metrics. And finally, we have managed data sources. You can see that our data model here looks a little bit like the keynote speaker that they were talking about in the data model. So we put this all together and we publish it to our Tableau Online instance, our Tableau online site, and the data model is the same for all of our users. Of course, a reporting solution or a data analytics wouldn't be anything without reporting. So we have parameterized reports. We have something somewhat innovative, I believe, that we call pivot and chart builders. I'll show you a demo on how we created those. That was a way that we took our pivot tables, our users that were used to pivot tables in Excel, and we transferred that knowledge over to Tableau implementation to ease them over. And then finally, we have start from scratch self-service templates. This is a slide of our data platform architecture. We have 4 distinct components. We have the collection component. Now this is where I want to tell you a little bit about loosely coupled interfaces and one of the design decisions that we made along the way that was a really good one. We knew that we would eventually be getting data directly from our data source via streamed JSON files. But they weren't quite ready to give us those files when we were ready to go to market. So we pulled data from our SQL Server database and wrote JSON files to S3. And by the way, S3 is nothing more than sort of file manager in the cloud. It's an Amazon service that's, I'm probably way oversimplifying for Amazon people, but it's kind of like a file manager in the cloud. So we would write those S3, those JSON files to S3. It turns out that that was a great decision because not more than a couple weeks ago, we stopped pulling data out of the database and we are getting it directly from the source now. It's very similar to the JSON files we were creating. So that's an example of loosely coupled interfaces and forethought in design. We use EMR, which is Elastic MapReduce, Hadoop, and Hive for our data transformation layer. We use data pipelines to orchestrate the movement of the data and the ETL. And then finally, we use Amazon Redshift and Tableau Online for the information delivery component. When we built our platform, the first thing we did is we thought about the different components and we considered the largest risk. We knew that information delivery was going to be our #1 risk and should therefore be our #1 priority. So we loaded data directly into Redshift without going through all the other steps to make sure that it was going to work and that we could connect to Redshift with Tableau and that the data volumes that we were looking at were correct. That was the right choice. We didn't go about it in quite the right way, and I'll explain that in a minute. The next most highest risk, the second highest risk, was transformations and data stores. We, quite frankly, didn't know what the technology, which technology we would be using and how it would work. So we felt like that was the #2 risk, and we went ahead and did that. Again, we made sure that everything was loosely coupled. We prototyped, and that's super easy to do in the cloud. You can spin up, I hear our developers all the time talking about spinning up a cluster. I'm going to spin up a cluster. Doesn't that sound cool? And so they'll spin up a Hadoop cluster, they'll spin up another Redshift instance or an EC2 instance or something. And these are all just ways that you can quickly and easily use those services within AWS, turn them on, try it out, prototype. If it doesn't work, you just turn it off. You don't have to get rid of any hardware, nothing. Works really great. Finally, justify complexity. Each of these components should be simple. The overall system may be somewhat complex, but you need to be sure and justify any complexity within each individual component. Now you'll understand by the time I am finished with this slide how our platform meets the presentation layer. So I mentioned earlier that it was the right decision for us to start with the presentation layer and load data into Redshift. And so we loaded data from a table that we had already collected that we were using for analytics before. And we loaded that data into Redshift and we tested it. Everything was awesome. It worked great. The problem is the data that we had collected was aggregated, and it was actually only about 1/3 the size of the data that we were actually ended up loading because we wanted, again, transaction level data. So the thinking was correct. The implementation, we missed on that mark. The reason I'm telling you that today is not to point out all of our foibles, but I'm telling you so you don't make the same mistake. If you go in and load the data in the quantities at the level of detail that you want into your data presentation layer or into your data persistence layer, you'll be better off. Understand your table usage. Put thought into how your tables are joined and queried and build accordingly. Understand the joins and frequent filters because data distribution and are key factors in creating an optimized table in Redshift. We also found that some aggregation was necessary. You remember our guiding principles stated that we wanted transaction level data. But the fact is that performance just at 1 billion rows isn't fast enough. So we had to aggregate data to some extent. Think about your aggregations and think about which fields you really need in that aggregation. Hopefully, everybody's listening now, because I think this is the coolest thing that I'm going to talk about today, engineered tables. Why we do this is because transactional data isn't written for analytics, right? Those guys that are writing these transaction systems that are running really fast, they're writing that so that they can read to it and write to the database quickly. They're writing transaction level details that don't necessarily make sense. So let me show you an example. What an engineered table does is it takes that transaction data and it makes sense of it in business context. Let me show you an example here. So I live in Bellevue, not far from Tableau, and my daughter, Bella, has a lot of animals. This is her cat, Pete, and Pete is actually a girl. We'll talk about the naming there in the naming conventions section of slide. But Bella went away. She went away. She's got all these animals, right? She's got the dog. That was Pete, the cat. She's got a fish. She's got chickens. So she went away to Spain and studied abroad for a couple of months. And she said, Dad, I need you to feed my animals. And this is her truth table. She didn't actually write out a truth table here, but we're going to make like she did. And then I was supposed to, as she was gone, I was supposed to keep a transaction table. So here you can see on January 1st, I fed the dog in the morning, fed the dog at night, cat in the morning, fish at night, chickens at noon, chickens at night. Now we can all look at this and we can look at the truth table and we can say, oh yeah, you overfed the chickens, right? That's what her chicken looked like when she came back. But the reality is, when you're talking about billions or millions or billions of rows, and you're talking about payment data, global consumer payments, there are a number of different payment types. We have Visa, MasterCard, American Express, there's IBP, there's PayPal, all these different types of payments. And they all have a different definition of a payment attempt and a different definition of a payment when it's successful. So we have a big truth table, and we have a big transaction table. And so at the end of the day, we have this. This allows our business users, this allows my daughter to get after me for overfeeding the chicken, but this table at Expedia, this engineered fact table, allows us to give our users access to the data that means something to them in a business context. They can now go in and analyze the data and know, was Tad feeding the animals correctly? What's our payment success rate? Self-service analytics. I'll tell you a little bit about how we use the impermanence of the cloud, how we maintain familiar concepts, and then our overall self-service methodology. So evaluation best practices, we started with spinning up an EC2 instance. That kind of sounds cool, but it's not really as cool as it sounds. All this is EC2 instance is basically a virtual machine in the cloud. So you can go to Amazon, sign up, and click on the EC2 thing, and then you can spin up a machine, and that can be a Windows desktop machine, it can be a Mac desktop, it can be Linux. So in our case, we spun up Windows machines, and they basically looked like our desktop machines or our laptops. We then loaded software onto those machines. And we had a list of business requirements, and we evaluated each of the products that we looked at against those business requirements. And then we simply dropped that EC2 instance. We didn't have to get it re-imaged, nothing else. We simply just dropped it and then started over. So here we'll talk a little bit about some of the familiar concepts. You can see on the left side here is our legacy cube. That's our SQL Server legacy cube, and on the right-hand side is the Tableau data source. Aside from the measures and dimensions being switched around, they're very similar. Right? I think if all of you were used to using the cube on the left, you'd be able to open the cube on the right and say, oh, I get that. I know where to look. We did this by using numbering, so that makes everything sort in the same way that it sorted in the legacy cube. We also used folders. I don't know if any of you are using folders in your data sources, but it's a great way to organize how your dimensions and measures are presented. We spent a lot of time and effort and intentionality in calculating measures within our data source. We use project folders. Now again, our users were used to opening a spreadsheet and creating a pivot table or a chart or something and then saving that. So we thought, hey, this would be a great idea. Every user will just create a project for each user, and we'll give them permissions on their project, but they won't have permissions on somebody else's project. And after we got to about 100 users, we realized this was an administrative nightmare. So we ended up consolidating our projects into projects that made sense for organizational units. One other thing that we did here that I would recommend doing differently is you can see that the acronym GCP, or maybe you can't see that, but it says GCP on a couple of these. And GCP was the acronym that was the bigger group. Anyway, that's changed. And for all of you that work in corporations for any length of time, you know organizations change and those acronyms are going to change. So maybe it would be a better idea to call these projects something like product management or project management instead of putting the acronym before them. Then finally we have reports. And we have parameterized reports or dashboards or whatever that everybody's used to, right? We have pivot builders, and these pivot builders allow us to choose specific dimensions and measures, and our users can drop those down, just use the drop-down boxes and change the measures and dimensions. So they can actually do self-service analytics without having to know and understand the full Tableau user interface. This is a great baby step to get users to adopt to your new platform. And finally, we have editable templates. Tableau Online and Tableau Server both now, you can open up edit capabilities in the cloud or in your server instance. So people don't even have to have desktop. You have complete edit capabilities within the online version. So now I'd like to switch over to the demo. And this is a demo of a pivot builder. So this is the end product. Thank you, Celia, for telling me to start with this. And you can see that my users, for example, can choose the dimension of segment. And now segment shows up on the report. And then maybe they want to look at customer name. And all the customer names show up. And then dimension 3, maybe they want to look at what products each customer purchased. And then they can choose different dimensions, or I'm sorry, different measures. So they can look at sales and quantity, for example. Okay? This is a very simple example, but it gives you the concept. Now, the way I did this is I created parameters. I first created parameters for the dimensions. And I chose specific dimensions. You can choose any dimensions you want that are in your data source, clearly. You can choose hierarchies and everything. So that's what I chose there. All three of the dimension parameters are identical. And then the measures look very similar. I created a parameter that has the measure names in it. I then created calculated fields for the measures and dimensions. I'll start out with the dimensions here. So you can see that if the parameter, dimension 1, equals customer, then use the customer name field. If the parameter, product name, and so forth. I did the same thing with measures. They're slightly different because you have to add the calculation in there and use the attribute function. So again, here you say measure 1. If the attribute or the value there is discount, then sum of discount. If it's profit, then average of profit, and so forth. I then dragged my measure names to filters and filtered out only the 2 calculated measures that I have created. I dragged measure names to columns, and then my 3 calculated dimensions to rows. Finally, I dragged measure values to the text field, and that actually presents the data. So that's a simple way to do that. The other thing that's kind of cool here is with a few clicks, I can take the measure names off of here. I'll take a couple of dimensions off because we don't really need all of the dimensions. And let's change that's to segment. And then I'm going to put the order date up here. And let's put measure values here. Now we actually have a chart builder. So you can do essentially the same thing with a chart builder or a pivot builder. All right. Let's go back to the presentation now. Tableau best practices, lessons learned, and optimizations. I've been pretty candid with you about some of the things that we did right and some of the things that we would have done differently. And I have a few more of those examples here. This is something we did right. We abstract all tables using views. So we do this because database developers, architects, designers, they're creative. They like to be free. And they might want to change the names of some fields. They may want to change ordinal positions in tables. I can see some database developers out there grinning at me. They may want to add new data. We want to get new data, and they want to add it, but we're not quite ready to bring it into our data source yet. So by having a contract with the database developers that says we want these fields in this order, or we want these fields and this is how they should be calculated, or we want them filtered in this way, and we have a contract with them, then they can give us that view. We have views for all of our dimension tables and our engineered fact tables. We join those together in our data source. The other kind of cool thing that they can do with views is our developers can go ahead and bring in, say, new data. They can make changes. They can do different things. We have two different production environments. We have a production A and a production B. Currently, we're on production A, and in the meantime, the database developers are doing some cool stuff on production B. Once they get that up and running, everything works, all the QA is done, all the testing is done, they simply switch where the views are pointing, and now the views start pointing at production B. Now, of course, we don't have any downtime for our users. Our developers don't have to sweat a big release. We just simply swap the views out. So those are two very good reasons for abstracting tables using views. Naming, generic, descriptive, and readable. Okay, so we made a little mistake here. This was the name of our original data source, payment attempt summary daily. Good, right? Generic, descriptive, readable. But then we decided, hey, we'll put the release number on it because that way we'll know what release we're on. Well, the fact is data sources kind of live in perpetuity. Because once you release a data source, and especially if you have adoption, which we're all looking for, lots of people are writing reports that are looking at those data sources, and so you can't change the name of that data source. You can't release a new data source and say, hey, everybody, start pointing at this one. It just doesn't work that way. So I think here with data sources, I would recommend that you keep them, again, generic, descriptive, and readable, and don't put the version number in it. I think we're up to version 1.5 or 4.5 or something. Anyway, we're way beyond 1.2.3. Some more lessons learned here. Don't try to extract 500 million rows. We initially thought, hey, Tableau's supposed to work really well with extracts, so we thought we would go ahead and extract our whole database. That didn't work so well. Hyper, it might work a little bit better, but really at the scale of that we're talking about at Expedia, extracts don't work very well. We only use them sparingly and when we have fairly small data sets that we can aggregate highly. All of our data sources are live data sources. They go directly to Redshift. And consider performance always. We have some really creative report writers and analysts on our team, one of them in the crowd here, and they can do some crazy, amazing things. One time we had a customer that said, hey, I'd really like to be able to see this report where I can just click a button and it will show me week to date, or it will only show me through last week. And of course, that's possible. We did that, but what happens is that the query to figure out that date math gets run back and forth on Redshift, and it goes out to Redshift, and it runs the date math, and it comes back, and it really slowed things down. So be sure you always consider performance when writing reports. Edit the XML to change environments. I'm not going to go into a lot of detail here, but if you have two different schemas on the same database, you can actually change between databases, and I'll show you that in the next slide, using the Tableau user interface. But in order to change between schemas on a data source, you have to edit the XML. So this is one of those things where Tableau, they really listened to us. And we said, hey guys, we need to be able to change the server that we're looking at on a data source. So this is the data source section of Tableau server. And you can see that if you click on the little ellipsis, there's an edit connection. Maybe this is old hat to everybody, but this was big news for us because up to this point we had been hacking XML and it was ugly. So then you can just edit the data connection. You can put the IP address or the name of your server, the server port, and the username and so forth. Tableau optimizations. So again, aggregations, we talked about that a little bit. Make sure you only include those fields that you know your users are going to be using and querying often. Assume referential integrity. When you create your data source, this is a super simple thing to do, but so oftentimes overlooked. Click on the data menu and go down to assume referential integrity. And that will optimize the queries that are sent to Redshift if you're using Redshift. Consider performance when writing reports. I've sort of already covered that. Here's some data source optimizations as well. Create your calculations in your data source. So make sure that all of those managed metrics are right in the data source, not in the individual reports. Create hierarchies. So maybe you have cities that roll up to states, that roll up to countries, that roll up to regions. Hide any fields, anything that's empty or not used by anyone. Again, this is for extract performance if you decide to use extracts. Set default properties such as number formats and comments. And assign data types and geographic roles in the data source. So in conclusion, I want you all to think about those guiding principles I talked about at the beginning, and consider guiding principles for the current project you're working on or the next project you'll work on. Think about the engineered tables. What tables can be engineered? How can you provide that business context and the value? When you're going through the rest of the conference, think about all the different ways that you can make simple, intuitive, and familiar self-service. See if you can find some techniques that will allow you to keep a similar paradigm to what you're currently using. Write yourself an email and send it to yourself, and that way on Monday you can talk to your coworkers about how great Trombone Shorty was on Wednesday night, but you can talk to your manager about the value you got out of TC18 so that they'll say next year, wherever we're going, you'll go there. Thank you very much. Again, my name is Tad Buman with Expedia Group. Oh. Do we have questions? Do we have time for questions? No questions? No time for questions? Yes? There is a mic. Or you can just ask me because I can hear you and I'll repeat it.
At the start in your architecture, oh yeah, you have a strong accent, sorry for that. At the start in the architecture, you're going from a structured data in SQL Server to kind of semi-structure in JSON to go back into structured data in Redshift. Why do you do this architecture this way?
Well, the reason that we decided to export the JSON files is because we knew that eventually the transactional system that's writing to the SQL Server database would be giving us JSON files directly. So that's why we decided to do that. But I got to tell you, I had exactly that same thought. As a business analyst, I'm like, why are you guys doing this? Just pull it. It's structured already. We know it's going to stay in that same structure all the way through. They said because when they eliminate the database, they'll be giving us directly the data.
You had anticipated this move already.
Yes, exactly. Well, I didn't. Somebody else did. Yeah, feel free to step up to the mic there.
You said not to extract 500 million rows. What's the greatest extract that you guys use, ever used? And what's the configuration of your Tableau server, like core license-wise?
Yeah.
Just to get some reference parameters.
Yeah, I should have those numbers, and I really don't. The places that we use extracts, our data is highly aggregated, so we only look at it like by the week or the month. Right. But our transaction data goes down to the millisecond. Right, so that gives you some, and initially we said, hey, we're going to go ahead and load this millisecond data into an extract, and that didn't work. But I don't know where to draw the line.
Okay. One more
Ask a Tableau guy; those guys know.
Yeah, the Redshift question. So you said you're using Redshift. Do you have any issues with concurrency? What is your user volume? How many users do you have on the Tableau server?
We have 135 users. We don't have a huge user base. We're a fairly small group within Expedia, and yes, there are some concurrency issues. So we're actually looking at some other architectures currently, and I can put you in touch with somebody that can answer every question you could imagine. I'm a business analyst, so we have an architect and developers that can answer any questions if you want to come up to me afterwards.
Sure, thank you.
My question was around the two production instances that you talked about. Like, how did your team or did your organization have problems with synergies and being able to maintain these two instances?
Yeah, it is a bit difficult. So you have to be sure that you synchronize all of your code base initially. You've got to make sure that your data is loading into both environments. It is super easy to test and make sure that your data are in sync when you're looking across both data because they should be the same. But that is a bit difficult to make sure that everything is running together at the same time.
Yep, looks like we Indians have all the questions. So one of the problems which comes with the travel data is around hotels, the names not coming correctly. So how exactly you're taking care of the bad hotel names coming in and the hotel matching?
Well, at this point, quite frankly, we don't look at hotel names. No, because we're payments. We're looking at payments. And Visa comes across fine. MasterCard looks good. Amex, fine. Now, the fact is, we're going to bring in booking data at some point so that we know this booking, this guy booked at this hotel and paid with this type of card and so forth. But at this point, we haven't run into that problem.
Okay, thanks.
I think we're about out of time. One more question?
Yeah, I wanted to ask about security. Now more and more companies are becoming GDPR compliant and visualization becomes a task. when you want to encrypt PII data, is there anything that you're doing on that end while also having optimized view?
Yeah, once you talk to me afterwards. Yes, we actually have specifically chosen to not bring in PII data or GDPR data into our data mart for exactly those reasons.
Okay.
So I don't really have much of an answer other than we decided that for analytics purposes, that information isn't important. All right? Thank you all. Have a great conference. See you at the party.